6.4. We're looking now at the sine law. Sine law really is going to be talking about what happens instead of always having a right angle triangle to do trigonometry. What happens if we have other shapes of triangles? Those are the ones we're going to be looking at now. So as you can see there, not right triangles using the sine law. Let's get started. Use this diagram here, and let's go through and using A, D, C, let's figure out what H is going to be. So we're identifying this spot right there. All right, here we go. Well, I know they're giving me the B value, and we're talking about in terms of A's, so then we need to figure out for H. So that's opposite, that's hypotenuse, we're using sine. Go figure, we're doing the sine law. So sine of angle A is equal to the opposite, which is H, over the hypotenuse, which is B. All right, well, they asked us to write an expression for H. That means isolate H. So then we're going to multiply both sides by the B, and we've got H equals B sine A. That meets the first criteria there. Then the next one says, now we're going over into the triangle BDC. Let's also do the same thing right for H, but this time in terms of A and B. So we've got, again, from angle B, we've got opposite being H, we've got a hypotenuse being the A. So sine of B this time is equal to the H over A. Let's do the same thing, isolate our H. So that means multiply by A, those cancel off. We get H is equal to A sine of B. I'm going to make an aside note right now for you. In any triangle, the way that we like to label it is we will label angles as capital letters. Capital A, capital B, capital C. We'll label the side lengths with a small letter. So across from angle A is going to be small a. Across from angle B will be a small b, and opposite that angle C will be a small c. And that's what you kind of see start going here with the A's and the B's. Now it says, let's bring those together. We know that H is equal to B sine A, and H is also equal to A sine B. Well, if they're both equal to H, I can make them equivalent to each other. So let's do that. We're going to say that B sine A is equal to A sine B. I'm going to do one more step with this. I've got A's and B's on one side, A's and B's on the other side. What if I bring all the A's to one side and all the B's to the other side? Well, let's bring the small letter A over. So that means divide this side by A. Hey, let's divide this side by A. Those A's cancel off. Let's bring the small b to the other side. That means divide each side by B. Those B's will cancel off. I get left now with sine of A, capital A, over little a, is equal to sine of capital B over B. Now, I could have moved the signs instead of moving the side lengths. I could have moved sine of A and taken it under the other side. So it doesn't matter if the sign is on top or if the sign is going to be on bottom, but they both fractions have to be the same. What I mean by that is I could have went the B over sine of B equals A over sine of A, if I would have divided the signs over instead of the side lengths. This next one here is constructed understanding. I don't find overly helpful. I'm going to move on to the next section. So taking what we just saw in that construct the understanding there in the actually in the getting started, we're going to carry on further just like I started going through, dividing each side. I can take the sign on the bottom or have the sign on top. I could have done the exact same thing. Instead of breaking it up with my h going this way, I could have said, no, 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 no. Why not break and have this as my h? And then I could work with a's and c's together. Or I could have went the other way. I could have broken it up there. And then I could have had b's and c's together. And that's what they've done here, is they've done it with b's and c's exactly the same way. And the whole point of that is to come to this right here and say, I can use any of the three ratios, but I'm always going to use 2 out of the 3. So in any question, only use 2 out of the 3 ratios at a time. We can't solve for something when we've got 2 equal signs in there. We always only want 1 equal sign. And so there's your 2 versions of the formula. We can either have the side lengths on top, or you could have the angles up on top. What I would recommend is deciding which one should I use. Use the one that puts your variable, the thing that you're looking for, on top. Just one last step of algebra if you do that. Now notice this here. In this triangle, all of the angles are acute. Now, acute means the small, less than 90-degree angles. But what happens if we have an obtuse triangle? One like that. Something with an angle larger than 90. We can still use a sine law. However, what we learned in 9.3 is sometimes you're going to have 2 possibilities in the sine law. You're just going to have to watch out for that. We'll get to some of those as we work through. Okay, so we've got this question here, number 1. We're looking for determine the length of GH. GH, that's right there. Notice what we have for information. We have an angle. Then next thing information that we have is an angle. And then the next we have a side. Angle, angle, side. If you have angle, angle, side, we're using the sine law. So because there's a sine law, that must mean there's other laws. Yes, we're going to get to those. Well, there's no A's, B's, and C's. So we're going to have to use H, G's, J's. Let's make our sine law up here. We've got G. We're looking for a side length. So I'm going to put my side lengths on top. Use that version. We've got G over sine G. We've got H compared to sine H. And we've got J compared to sine J. All right. Well, which ones do we have information for? Let's go through and figure out what information we've been given. We've been given G. We've been given that angle G. Well, we don't know anything about the H, not the side length, but we could actually figure out this angle, because all angles in a triangle have to add up to 180. So we could figure out angle H by going 180 minus 51 minus 44 degrees. That would give us H. But we're not looking for little h, so you know what? I actually don't even care about that part of the fraction. And then we've got J is what we're looking for, but we do know the angle capital J. We know 3 out of the 4 things in those 2 fractions. That's what we're going to use right there. So I'm just going to rewrite it for myself. I like to put the one you're looking for as the first numerator, and then the fraction that you know totally as the second fraction. Let's fill in what we know. We know that we've got J is what we're looking for over the sine of 44 degrees. G, hey, that's 7.8 over the sine of 51 degrees. We need to isolate j, so multiply both sides by that denominator right there. Those ones will cancel off. We've got to multiply both sides though. And what we're going to punch into the calculator is going to be 7.8 sine of 44 degrees over the sine of 51 degrees. That's the exact value. But now as soon as we punch it in, we're going to get a decimal approximate value. So if they ever ask for exact value, this is where you stop and leave it. Make sure that along your algebra, I am going to need to see your formula, your substitution in your formula, your rearranged formula, and finally, your answer. That's going to be j equals approximately 6.9720 ... So we'll say j equals, they said, to the nearest tenth. That's 7.0 centimeters. Do a quick little check for yourself. If we're saying that this is 7.0, just quickly check. 51 is bigger than 44, so the side length opposite of the larger angle has to be larger. If 51 is larger than 7.8, then my answer's got to be a smaller. All right, next question. We're looking now for angle n. So that's what we're looking for there. So right off the bat, I'm looking for angle n. Let's put angle n on the top numerator. So that means I need to know side n. Well, wait a minute. Do I know side n? I don't right now. So something's going to be fishy there because I don't know this and I don't know that either. So there's got to be something else we're going to do. And there is. If I'm looking for an angle of n, I could find p and know that 180 degrees inside there. So I don't have enough information to go straight to n. So unfortunately, no go on that one. But I am going to find instead angle p to start with. Let's start there then. So then, angle p, using sine of p, is equal to, oh, I do have enough information for the side opposite, which is p, equals. Now I've got the other ones. These two together, they go as a team. So I'm going to use those ones, plug her in. So sine, if sine started on the top, got to keep going with top. Sine of 92 degrees over the 11.8. Always going to be the same. Multiply by that denominator, multiply by 10, multiply by 10. Those will cancel off. And I want you to put down your reduced version. 10 sine 92 degrees. Put the 10 in front. Over 11.8. I need to see that algebra. Now we're going to plug that into the calculator. And because we're looking for our angle here, we're going to need to get the sine to the other side, inverse sine. So what you want to punch into the calculator either is that fraction as it is, or you can do it in one step, inverse sine of that. I'm going to do it in 2 steps. I'm going to quickly punch this into my calculator. And I get a value of sine of p is equal to 0.8469 ... Got to get the p separated, so we're doing the inverse sine of that answer. Don't punch in the values. Use your answer button on your calculator, which equals 57.8805 ... So approximately to the nearest degree, 58 degrees. Now what do I need to see from your work? Well, we need to see, you're filled in here. We need to see this. We need to see your answer, and then round it. So all this work in between there, that's optional. What I've highlighted, that's what I need to see. Now comes the tricky part of sine law. What happens if we're dealing with obtuse angles? This is where sometimes you're going to have that ambiguous case, where you might have two triangles. And that's what 6.3 was developing. It was developing the rules to show when we've got this triangle or when we've got that triangle. Do we have two of them? What do we got? So we've got to know that because of standard position, which we've dealt with, just to quickly remind you, using the cast rule, we know that in quadrant 1 and in quadrant 2, meaning theta, or 180 minus theta, they're going to be virtually the same. So in quadrant 1 and quadrant 2, an acute angle in quadrant 1 is going to have the same value as an obtuse angle in quadrant 2. Just to show that diagram in a slightly different way, that angle as opposed to that angle, they would be the same. Just like in standard position, we had to do the thinking there to figure out which one we're talking about. We got to do the same thing here. Your calculator is only programmed with the small acute angle, not the obtuse angle. So if we're looking for this angle right there, G, I'm going to put it in there. We're going to work it through. Notice what happens as we go through the work. We come up with, oh my goodness, 57 degrees. Let's try that again. There we go, 57 degrees. But we know that that was supposed to be an obtuse angle. It'll always give you the acute. So therefore, we've got to do one extra step and do the thinking instead of the calculator doing the thinking. Subtract it from 180 to get 122. Before we move on to doing question number 3, we need to realize that sine law doesn't always help us out. There's times when we can't use the sine law. For instance, if we have a question like this. This one, remember that at the beginning I made mention to angle, angle, side? Sine law will work with angle, angle, side. What we have here is we have a side, and then the next thing is an angle, and then the next thing is a side, in that order. So SAS, no go on the sine law. Notice what happens if we try to use it. We're missing one thing from this. We're missing one thing from this. We're missing one thing from this. We don't have a full fraction. We can't use sine law. Likewise, if we have all three sides. So if we've got side, 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 or SSS, no go on the sine law. Because again, you've got one thing missing from every fraction. We can't find and isolate one of the variables. All right, let's check out this one. A triangle DEF. Let's draw it first, and we want to know that only one triangle can be drawn here. So let's start it up. I've got D to E to F. They're telling me that angle D is 80 degrees. They're telling me that D to E is 5 centimeters. And F to E is 8 centimeters. Ooh, look at that. Well, the question now again is, could this 8 centimeters have been here as well as over there? Could it have been in two spots? Oh, that was what we did in 6.3. We got to use the rule, and we've got to check. That's what part 1 is asking us to do. Use the rules developed in 6.3. Okay, well, the rule there is talking about the relationship, the ratio of DE compared to EF. So we're going to do that. FE compared to DE FE was 8 centimeters. DE is 5. Oh, look at that. That's greater than 1. So we need to look at the rule that says when FE over DE is greater than 1, or y over the r as we discussed it, is greater than 1. Oh, that's only one possible triangle. One scalene triangle. When they say solve the triangle, that means find everything else. Find this side length, find this angle, find that angle. We're looking for everything in this triangle. Let's start by looking for angle F. Well, we're going to say sine of F over F is equal to the sine of D, 80, over little d, 8. Oh yeah, we have enough information for sine law here. So let's look at our triangle again. We knew an angle, and then we knew a side length, and the next thing right after it is a side length. Oh, look at that word. This is the one, when you get this word, that there could be an indication, could be two triangles. That's the indication of when you've got to use the rule from part A there. It's the tough one. It's the donkey behind one. Now, just the same as we did before, multiply both sides by that denominator, and we get sine of F equals 5 sine 80. Again, please show that algebra step. And then you could jump straight to the answer by doing the inverse sine of 5 sine 80 over 8. That's what we'd punch into our calculator. F is equal to 37.9886 ... or approximately 38 degrees. That I'm going to write in there, that's 38 degrees. Oh, the next easy one to find, let's find angle E. Angle E is easy because we can go 180 minus 80 minus 38, which gives us 62 degrees. And that's approximately because this was approximately rounded 38. Write it into the triangle. 62 degrees. Last thing, let's find side E. Back to sine law. We're looking for E over the sine of capital E is equal to, well, I could use either angle. I'm going to use the one they gave me. I'm going to use the 80 degrees. So I'm going to say, with that one, it's going to be the D over the sine of D. Okay, fill it in. We've got E over sine of 62 equals the D value 8 over, what was that, sine of 80. Multiply up your sine of 62. Cancels off. Please show this step again. E equals 8 sine 62 over sine 80. That's what you punch into your calculator. Don't forget to end your brackets around the 62 when you punch it in. E is equal to approximately, what is that, 7.1725 ... So it's approximately equal to 7.2 centimeters. I'll write that down, 7.2. Now do a quick check for yourself. Does it all work out? 80 is the largest angle. That means the largest side has to be opposite. 38 is the smallest angle. That means opposite 5 has to be the smallest side. That is true for all of it. So yeah, we're probably not wrong. And now the fun one. We got another fire going on here. Fire Ranger doing this. So let's start drawing. Fire Ranger at point A. Let's put first Fire Ranger right there. Reports smoke 30 kilometers away. Oh, look at that. There's a missing words here. In a direction east 30 degrees north at B. There we go. So then we're going to go 30 degrees east north, or east 30 degrees north, sorry. There we go. Let's put that fire B there. That's 30 kilometers. Hardest part's going to be drawing these, I know. And now we've got a second station. I'm missing that word. A second station at C, due east of the first station. Let's put you right here. Report smoke 20 kilometers away, but they failed to give a direction. Doughhead would have averted all of this work if they would have just told us the angle, but they didn't. So we've got to now figure out. First thing, we're looking for the distance between the two stations. That's what we're going to try to find. But we need to know, is that B to C one triangle? Or could C have actually been here? I'll call it actually C1 and C2. The only way to know is to do the test. We're going to compare AB and BC lengths. And compare that to the sine of, oh, nice, they give us 30 again. So sine of 30 degrees, that's 0.5. BC over AB now, that's 20 over 30, which gives us 2/3, which is approximately 0.67. We can now say that BC over AB is greater than 0.5, but it's less than 1. So we've got, oh, lucky us, of course, you knew this was coming, 2 scalene triangles. Yahoo! We've got to deal with both situations, one here and one there. All right, so let's start with case 1, the acute angle. Case 1. Let's fill in the numbers again. That's 30, that's 30, that's 20. That was A, B, and C1. We're looking for that distance there. Let's first of all find angle C, then we can find angle B, then we can find the third. Step 1. Find your C1 angle. We're going to find this angle. So sine of C1 over 30 equals sine of 30 over 20. So sine of C equals 30. Sine 30 over 20. Punch it in and inverse sine. We get about 48.6 degrees. Okay, good. Step number 2. Find angle B. Well, that's 180 minus 30 minus 48.6 gives us about 101.4 degrees. Good. Write it in. Step 3, find A to C. Sine law again. So we'll just call this little b. So b over sine of the b equals, let's use the 30 that they gave us. We're going to say 20 over the sine of 30. So b is equal to 20 sine 101.4 over sine 30. Punch that into our calculator. We get approximately 39.2 kilometers. But that's only true if we had an acute angle for C. So there we've got case 2. Whew. A little bit tougher of one. Let's look at what to do with this one. So I know that this over here was 48.6 degrees. I also know that this is an isosceles triangle. So that means here is 48.6 as well. That means here we're going to have angle C equal to, because this is a straight line, 180 minus 48.6 degrees. That gives us 131.4 degrees inside here. Well, now I can find angle B. So then angle B is equal to 180 minus the 30 minus the 131.4, grand total thereof, 18.6 degrees. And now we just got to look for that little b again. Hey, we're back to sine law. So b over sine of angle b equals, let's use the 30 again. So 20 over sine of 30. That gives us b equals 20 sine 18.6 over sine of 30. Punching that into the calculator, we're almost done. 12.7583 ... So 12.8 kilometers. So just bring it together, written question, written answer. So the stations are either, from the first one, 39.2 kilometers, or, we don't know which one, 12.8 kilometers apart. Woo, would have all been solved if they just gave the angle at the beginning. Woo, pretty intense, that ambiguous case. It is. Please bring it together, kind of explain it for yourself. We're going to go over a bunch of ambiguous case ones because those are the tough ones. Have a good one.